In this video, I will explain you the possible numericals based on image formation. Okay. Remember, when you are doing these numericals, you need to do it on the graph. Okay. Suppose it is written 10 centimeter. Okay. Now it's not a requirement that you need to do this 10 centimeter. Okay, because it's a graph, you are creating the image on the graph like this. So you can consider the whole block is 2 centimeter or 3 centimeter or whatever you can consider like this. So if you need to do 10 centimeter and you are considering the block of one graph is 2 centimeter, then you need to do 5 centimeter. Okay, so you can scale according to yourself. Now, a converging lens has a focal length of 10 centimeters. So, focal length is given. Focal length means f equals to 10 centimeter. And what is focal length? If you have seen the videos, the previous video, I have explained you what is focal length. So, focal length is basically it. If it is a convex lens, from optical center to focus, this is your focal length. Okay, I've explained you in my previous video. So first of all, focal length is given. So look here, I made this convex lens. This is the convex lens, and I've created this center line. Okay, this is your first step. Now after this, you need to create focal length 10 centimeter. This is my optical center O, and this is 10 centimeter. I have measured it and I have done it 10 centimeter. So what will be 2f? 2f will be 20 centimeter till here. Okay, so this is all measured. Now see the first part. A object is placed 30 centimeter from the lens. Construct a ray diagram. So first of all, what we need to do? We need to construct a ray diagram. Find the image distance and describe the image. So you know, when in my previous video I have discussed all the 6 cases where I have described the image. Okay, so you are well aware how to describe the image and find the image distance. There is a formula. I will show you now how to find the image distance. Okay, so now consider the first part. First of all, we will create so in this it is mentioned object is placed at 30 centimeter. Okay, so till here is 10, till here is 20, 20, it is 10, and this is basically 30 centimeter. Okay, so this is 30 centimeter. Now I am removing these because I need to create a diagram. So this you need to, when you are making it on the graph, you need to consider by yourself what is the distance. It is very important. If you will not see the distance, the image will not be proper. So what is the first rule? We need to construct a ray diagram. So first rule is any ray which is parallel to the principal axis will pass through the focus. So this ray will pass through the focus like this. Okay, second rule, so I'm just constructing an arrow like this, and second rule is any ray which pass through the optical center will pass as it is. So this will pass through as it is. And the third rule, any ray which pass through the focal center, okay, will be parallel to the principal axis. So these are the 3 rules. They are very simple. In every image formation, you need to follow these rules, and then it will be a image here. Okay, you all know I have explained you if I need to describe this image. So this image will be real, inverted, diminished. Okay, because you can clearly see the image is smaller than the object. This is a description of the image. Okay, because you are measuring, you are doing it on the graph, so you can clearly measure your image, what is your image length and what is the object length. Okay, so now we need to find the image distance. So for this we need to use this formula. Okay, the formula is 1 by p plus 1 by q equals to 1 by f. This is called the thin lens equation. Okay, thin lens equation. You need to remember this equation where this f is the focal length, q is the image distance, and p is the object distance. It's very simple. Now in the converging lens, in the convex lens, we learned f equals to positive for convex lens and f equals to negative for concave lens. Okay, I have explained this thing in my previous video. So we need to find q. So I'll just put all the values in the formula. 1 by q equals to 1 by 10 minus 1 by 30, and by this we calculate q equals to 15 centimeter. Okay, so this is my answer. So you need to find q, and then you need to find magnification. Magnification means the image is magnified or diminished. Always remember, magnification is denoted by capital M and its formula is minus q over p. Okay, so now minus 15 by 30. Okay, so it is minus 0.5. So you can see that this is minus 0.5. That means it is smaller than the object. So minus 0.5 is the magnification of the image. So this is my another answer. Okay, so it's very simple. In every question you need to construct this ray diagram. Okay, after ray diagram you need to find the image, object, focal, whatever is asked in the question, and then the magnification. Okay, and remember, if you are using the convex lens, then f equals to positive, and if you are using the concave lens, f equals to negative. Okay, let's move to part B. An object is placed 10 centimeter from the lens. Find the image distance and describe the image. Draw the ray diagram. Okay, now it is asked an object is placed 10 centimeter from the lens. Okay, and then we need to find the image distance, describe the image, and ray diagram. Same as part A. Let us see what will happen to part B. Okay, now this is the same diagram. Focal length 2f, optical center. I have done everything here. Now this is object and it is placed at 10 centimeter from the lens. Now the first rule. What is the first rule? Sorry. So the first rule says an object principal to the parallel to the principal axis will pass through focus. Second rule, line from optical center pass through this. And third rule, because the object is already at focus. Where's the B part? Yes, this is the B part. Okay, because object is already at focus, now we need to find the image, because now you can see on the right hand side it is not meeting, so we need to extend it. If I am extending it, you can clearly see they are going to meet somewhere. Okay, but where? So this case is similar as discussed in my previous video, when the object is placed at focus. Okay, so what is the image description? Image is highly magnified. Okay, second is images will be virtual because it will be on the same side of the lens, okay, and image will be at infinity, okay, because it will be very very far, so we are considering it is the image is at infinity. This is the image description. Now again, if we need to find the image distance, okay, we can verify it. 1 by p plus 1 by q equals to 1 by f, the same formula, and we are going to use this formula, and this is basically the thin lens equation, okay. So we will find 1 by q equals to 1 by f minus 1 by p, and then we will put the values. Focal length, what is focal length? 10 centimeter is given, and object distance is also 10 centimeter. This is given, okay. We'll put the values and we will see q equals to infinity, okay. So this is basically the image distance. Now consider the C part. Let's see what is the C part. An object is placed 5 centimeter from the lens. Construct a ray diagram, find the image distance and describe the image. Same question. But the difference is now the object is at 5 centimeter. This is my object here. We didn't mention. Always remember to mention what is your object. This is your object. And in A part also, I forgot to mention, this is your object and this is your image. Please mention object and image in the ray diagram. Now it is the C part. You can see. So the first rule. Okay. What is the first rule? Parallel to the principal axis will pass through the focus. Okay. This is your first rule. Second rule is, this is your optical center. Any ray pass through the optical center will pass as it is, like this. Okay, and focus we will not do. So this is not meeting on the other side of the lens, it is also meeting here. We will just extend it. Okay, so it will be meeting on the same side of the lens. See, these are meeting here. This is your image. I'm mentioning here, it is your image. So you can see that what is the image description? It is virtual because it is on the same side of the lens. It is magnified. Okay, and distance, we can find out the distance now. What is the distance? If you are doing it on the graph, you can easily find the distance here. Okay, and this is your image description, and we will use the same formula, 1 by p plus 1 by q equals to 1 by f. This is your thin lens equation. Okay, and 1 by q equals to 1 by f minus 1 by p. What is given to you? Q we need to find out, and focal length is 10 centimeter. It is given. Object distance is 5 centimeter. Okay, so when we find out q equals to minus 10 centimeter, now you can see it is minus 10. That means because the image is created on the same side of the lens. So basically the image is at the focus. Now m equals to minus q by p. So m will be 2. So you can see here m is positive 2. That means the image is magnified. You can see from the diagram the image is magnified. Okay. So by this we have find out the image. This is your answer and this is your answer. Now consider the D part. Let us see what is the D part. Construct a ray diagram in graph paper if a real and inverted image of height 4 cm is located at a distance of 20 cm from the lens. Okay. Now in this, please note, in this a real and inverted image of height 4 cm. Okay. Image is given to you. You need to construct a diagram. Okay. So consider the D part. Yes. So in this, image is given to you at 20 centimeter. So this is image 4 centimeter and 20 centimeter. So we will use the same rule, but now the image is given to you. So how we will do the same rule? So the first rule, we will start with the optical center. Any ray passes through the optical center will go as it is. This is your first rule. Second rule is the ray which is parallel. Okay, the ray which is parallel. Okay, I am here considering here. The ray which is parallel to the principal axis will pass through the focus. Okay, second rule. And the third rule is the ray which passes through the focus. The ray which passes through the focus will be parallel to the principal axis. Okay, so the image will be at 2f. So sorry, this is now the object. We created the object, and what was given? Yeah, image was given. So this was the rule. We'll just do the arrows. Okay, so this is the ray diagram. Okay, always remember those 6 cases I've explained you, when the image is at 2f, where will be the object, and these there. So this is the ray diagram for the D part. Now consider the E part. An object is located 30 cm in front of a lens, forms an image on a screen 17 cm behind the lens. Determine focal length and magnification. Is the lens converging or diverging? It's very simple. Object is located 30 cm in front of the lens, forms an image on a screen 17 cm behind the lens. Okay, so image and object both are given to you. Okay, this is E part. I have constructed it. Okay, and it's very simple. Object is given. Object is at 30 centimeter. So this distance from optical center, this distance is 30 centimeter. Okay, object is located. So we will follow the same rules. The first one, any ray which is parallel to the principal axis will pass through the focus. This pass. Second, will pass through the optical center as it is. And the third rule, any ray which is passing through the focus will be the parallel to the principal axis. So this is your image, and you can see the image is diminished from the object. Okay, so if you will measure this distance, so this distance will be basically 17 centimeter, which is given in the question. Okay, now we'll use this thin lens equation. Always remember to use this equation, thin lens equation. So 1 by P plus 1 by Q equals to 1 by F, and P is the object distance, Q is the image distance. So we have done the formula, and by this we can see focal length is 10.85 centimeter. Okay, so we have calculated the focal length, and then magnification equals to minus Q by P, and minus 17, magnification is minus point. See, the magnification is in negative. Negative means the image is diminished. You can see the image is diminished here. Okay, and since I told you when f equals to positive, that means the lens is converging. Okay, So lens is converging, because in this question it is asked the lens is converging or diverging, so we don't know. So when you are making on on the graph, so just create a line like this, don't make any lens. Okay, just create a line. So because I know it was a converging lens, so I just did it. But when you are making, just draw a line like this. This is the center line, and then you construct a ray diagram and lens, because it is not given to you. Okay, so these are the 5 type of questions, and I think we have done so many questions based on it, and you can do any image formation because you know the basic rules of how to do the image formation. Okay.